All right, hello, welcome back. We are looking at data representation, and you're saying we've done that before, Mr. Kravis. Yes, we have. We've done it for science. We're doing it for math. But again, since we've spent so much dang time looking at tables and graphs before, I'm not going to belabor this video. I'm going to try and keep it pretty quick. And again, with these sorts of data rep things, there's going to often be like way too much text. And it's often nice to jump to the end of these questions and say, oh, how many 1-foot squares of blue material does Lance need to make his flags? Okay, great. If you got a big old table, you're not going to have to use all that data. It's too much. Focus on the data you do need. Blue, Lance. Okay. The table with colors tells how many 1-foot squares of each color are needed for each size of flag. And the table with names tells how many flags of each side the person's to make. Okay, great. So what's Lance going to do? He's going to make 3 medium and 3 large flags. What does a blue flag require? 3 for medium and 5 for large. So this is going to be what? 3 mediums times 3 squares apiece plus 3 larges at 5 squares apiece. 9 plus 15, hot dang, 24. That looks like a terrible, I mean, look at how many words there are. But it's not asking you to use all that data from the table. Focus on what it is asking for. Use your word search sorts of ideas that we developed in science. It's useful in math. Number 2 is a good one. It combines some ideas from the previous one about linear equations. Johnny's selling lemonade, paid $5 for supplies and charges $50 a glass. All right, profit is found by subtracting his expenses from his income. Okay, great. So profit equals income minus expenses. All right, what's his income? He makes 50 cents a glass. What's his expenses? $5. Great. We've just made the equation of a line. So we're looking for what? Something with an intercept of -5. He doesn't sell any lemonade. He doesn't make any money. He's got to sell at least 10 glasses to get out of the hole. There's only one reasonable answer here, and it's K. And that's because he starts in the hole. He hasn't made money. He just went and bought some supplies. He hasn't sold any lemonade yet. So if he sells 0 glasses of lemonade, he has lost $5. So we can use tables with way too much information and zoom in on the information we need. We can find linear equations for descriptions of a process. Great. Number 3 is a beast. I just want to tell you that this is a beast of a question. I think this was towards the end of a test. In a large high school, some teachers teach only one subject and some teachers teach more than one subject. Use the information given the table below about math, science, and gym teachers in the school. How many teachers teach math only? So I just want to, if we were looking at a Venn diagram, math only, that would be how many people are in this black region, which does not overlap with science and it does not overlap with gym. Math only. And think about what these other regions are. Those are the math and science teachers. Those are the folks that teach everybody. Gym and science, gym and math. You can work through this problem, and intuitively, there's a guess that's pretty straightforward. I want to talk through it just because I like Venn diagrams. I thought this one was cool. This is a problem that would take you a long time. I suppose most of you look at this and your eyes glaze over a little bit. Okay, let's start filling in. We're trying to find the black region. Let's find some adjacent regions. All right, at least one class of math. So I know the total in this, I'm going to use a different color here. At least one class of math. It's 12. I know in this blue circle, I'm going to have a total of 12 in there. Great. Does that help me? Well, I know I know right away 2 answers it can't be. Can't be J or K. Only 12 math teachers. What else do we know? Well, we can start. We know some of this. This is gym, science, and math. That's everybody. So there's 1 in there. Great. What else do I know? Do I know science and math? Science and math, but not gym. Okay, so the science and math people, there's what is that? Science and math, but not gym. That's going to be 5 right there. Okay. What don't we know? Well, okay, so it's got all right, so that doesn't it's got to be less than 6. What about Jim? I got a total of this is a long problem. I wouldn't probably actually do this for most of you, but I'm just entertaining myself here. Jim, I'm going to have a total of what, like 10 in there. What else do I know? Jim only is going to be 2. Um, what else do I know? Gym and science, but not math is going to be 6. Ah, okay, so I'm there. So I've got 10. 10 in the big circle here. I've accounted for 2 and 6 make 8, and 1 more make 9. So this has got to be a 1 in here. If my total here in the green circle is 12, and I've already got 7 accounted for, I've got to have 5 in there. Answer is H. That one is a bear. That is a beast of a problem. You guys done 3-way Venn diagrams like that? No. Just thought I'd show it to you or give somebody, that's for the person trying to get a 36 or something, get above a 30. So don't worry too much if you didn't get that one. I do want to look at something like a 2-way table, though, maybe something you haven't seen before. Teacher asked all the students in the junior class about the number of cats and dogs their family had. Results are in the table. How many students answered that their family had 1 or more cats? Well, 1 or more cats, those are the people who said 1 or more cats, yes. We didn't care about whether they said dogs or not. Not important. 48, 66, 4, carry the 1, 1, 1, 4. So we can answer 2-way tables as long as you know if it asks us about 1 or more cats, it didn't ask us about dogs. We didn't care what their dog answer was. We just cared about their cat answer. And recognize you can kind of break up those 2-way tables kind of like that. Now, if we had asked how many families had 1 or more cats and 1 or more dogs, that would have just been 48. But there we are. Let's skip 8. I want to look at number 11 because I keep getting questions about things like number 11. The area of a circle A varies directly with the square of the radius r. Okay, we've talked about varies directly. We saw it yesterday. Most people ask me questions about it. Recall that y equals kx, that's what directly looked like. And y equals k over x is what inversely looks like. So we're told that the area varies directly, so it's going to be on top, with the square of the radius r. A is equal to kr squared. So what's a squared function look like? Hopefully you know this is linear. Hopefully you know this is also linear. That's a circle. I don't know what that is. This looks kind of like a square root function or a log function. I don't know. But this right here is a quadratic function. So you need to know what quadratic functions look like. What does it look like to be squared? Well, it's going to look something, something like that. Cool. So you got to know what directly means. You got to know what some basic graphs look like. One more for you, I think. 3 more for you. You're going to have these distance time graphs, and we saw these in science. All right, so we took a trip. Which one best describes what happened during the interval from 2 to 4 hours? 2 to 4 hours. The distance didn't change. The distance doesn't change. Well, the car stopped. So it's got to be J or K. The car was stopped. Now the question is, are there 150 or are there 100 miles left? You say how many miles are left here. That goes from 100 to 250. Pretty clear there's 150 miles left. So you got to be able to look at distance time graphs. You've looked at these before. We looked at them in science. So quick reminders there. And the last one looks like something we've seen before. One of these sinusoidal graphs, looks like a sine wave. It's about boat sales, ski boat sales, but people buy ski boats when the sun is out, and the sun does something like this. Which of the following is the value for the September 2005 on the model curve? Which one? September 2005. On the model curve, it is 20. The actual value is 24, but the predicted value looks like 20. This is a question, looks like it came straight out of science. Another one, number 18, I think the last one I've got for you, which looks like a question straight out of science. What is the average number of ski boats actually sold per month between and including the months of January to April 2006? Average from January to April 06 for actual numbers sold. January, February, March, and April. How do you find the average quickly? Add them up and divide by how many you got. 6 plus 15 plus 20 plus 30. Enter. Divide by 4. Got an answer 17.75, which goes along with answer option D. I think that's all I really wanted to show you. These are just kind of goofy, and you got to look at them. There's not that many problems here, you'll notice, but they do take a minute to read. 43 questions. I'm going to say if you do 30 of them, you're good. So if you got all the way through the video, you've got an excuse to not do more than 30. But don't tell the people that didn't watch the video. They're cheaters. Good deal. See you next time.